So today I am presenting on, and all 3 days, reasoning-focused word problem-solving instruction for elementary, and specifically how to use the schema-based instruction procedure method. Today is really going to be an overview and an introduction to what is schema-based instruction and why should we use it in elementary. On the next 2 sessions, we're going to get deeper into how to use the strategy. Today, we're really looking at what is it, why do we use it? So welcome. As Cami introduced me, I'm Stephanie Morano. I am an assistant professor in the special education program at the Curry School at UVA. This is my first work event out of maternity leave. I'm really excited to get sort of back in the swing of things with you all here today. I have a 3-month-old, 3 months old yesterday, who is on a walk with dad right now. So we won't hear her screaming, which is wonderful. I've been at UVA for a few years. Before that, I worked as a volunteer for the Peace Corps doing special ed development work in the Eastern Caribbean, in Grenada for a couple of years. And before that, I was a classroom teacher. I was a special ed teacher. I worked in elementary. Most of my own research and most of my teaching at UVA is focused on how do we support students with disabilities in improving their math performance. So that's what we're going to focus on and specifically talk about word problems today. Cami shared with me that the group we have today is about 1/3 lower elementary, 2/3 upper elementary, and the content we're going to look at should work for everybody. So I'm going to go ahead and share my plan for you for today. We did a quick welcome. We're going to talk about why word problems are so hard for some students and for some students with disabilities. We're going to look at what does ineffective word problem instruction look like. Then I'll do some introduction on what schema-based instruction for word problem solving looks like. We'll do a quick overview of the additive schemas, and then we'll close out for the day. If you have questions that come up at any point while I'm talking, please type them into the chat. I'll try to keep an eye on that so that as questions come up, I can answer them, and Cami's going to help me notice questions if I'm sort of focused on something else and I miss it. But please do type into the chat with questions as they come up. I would love for this to be as interactive as possible. Okay, so as special ed teachers who work with elementary age students, we know word problems are an area that's can be really challenging. I like this study is getting a little bit old. I wish the researchers would do an updated version, but I really like this study from 2008. The researchers looked at all of the literature on math instruction and math intervention for students with disabilities, and picked through to identify all of the specific behaviors that are associated with difficulty with math, MD, math difficulty. And then they asked teachers to rank order those behaviors to say how often they see each in their classrooms. So special ed teachers, out of the 29 behaviors ranked, has difficulty with word problems as the most frequently observed in their classroom. I think is really telling, and I don't think it's changed in the 12 or so years since this study was published, based on my conversations with teachers and interactions with teachers. So I want us to think about just for a minute, what skills are needed to solve word problems, or sub-skills? What's involved in solving word problems? And why are word problems so difficult for students with disabilities? So let's take a moment, type into the chat if you would. What are some of the skills that students need to be able to solve word problems effectively? I am not seeing the chat right now. Let's see if I can.
Well, you have a lot of word reading comprehension. That's primary what the response is: reading comprehension, reading, spelling, comprehend, math, vocabulary, and language. If that helps you out.
Yeah, so that's great. And on the next slide, you'll see the first thing listed here is reading the problem, understanding the meaning of the sentences, understanding what the problem is asking. So those are all reading comprehension related. Being able to identify extraneous information or the parts of the problem we don't need to solve, coming up with a plan to solve, working through multiple steps without getting lost, and using correct calculations. So basically, all of the sub skills involved in problem solving are challenging, and particularly challenging for students with disabilities. And if we think about why, there are three big reasons in general why math can be a challenge for students with disabilities. The first one is limitations in domain general or cognitive skills. So by that, I mean things like working memory, attention, processing. Knowledge and skill gaps. So in relation to word problems, the knowledge and skill gaps that are most important are in basic fluency, math fact fluency, and computation. I lost it. And then affective characteristics, things like low self-efficacy in math or low motivation for math. So those are three big reasons why math is challenging in general. And all three sort of feed into why word problems in particular are really challenging for students with disabilities. All right, so now we're gonna transition and talk about what some ineffective instruction for word problem solving looks like. A big culprit is the keyword strategy. I think everybody in elementary has seen a poster like this in a classroom, keywords for solving problems. Before I move on to the next slide, let's think about what are some of the keywords that we typically associate with problems where you would use addition to solve. So go ahead and type that into the chat if you would. And Kenny, I'm still not seeing the chat. If you would read it out, what people are saying, that would be helpful for me.
Absolutely. So we have add, in all, plus, how many total, lots of totals, together, of, some.
Yeah, I think you may have gotten all of them there. Add,
all together.
Total, plus, and all. Or you may see some others on other charts. This is just an example. But we've all seen these. We all know what these keywords are. So what we're going to do is we're going to do a breakout group activity that's going to help us sort of start to understand why teaching the keyword strategy or teaching students how to sort of hunt for those keywords and then use them to solve a problem can actually be detrimental for students' problem solving learning. So what you're going to do is you're going to open up or find in your folder this document, the keyword strategy activity. And you're going to work with your group to first identify the keyword and associated operation for each problem, then solve using the keyword that you identified, and then evaluate. So is your solution correct? If not, determine what the correct solution strategy would be. And then when you finish that, that work, I want you to talk with your group mates about what are the potential pitfalls of teaching the keyword strategy. So think about what's really the point of problem solving instruction? Why are we teaching problem solving in the first place? What skills and competencies involved in problem solving do we want students to take out into the real world with them? And does using the keyword strategy support those goals? Why or why not? So some things to think about after you do the first part of the activity here. So you've got 4 word problems listed here that you're going to just talk through and solve with your group, again, using the keyword strategy. So find the keyword, determine which operation that keyword is telling you to use, go ahead and use it to solve and then evaluate. Were you right? Did you make a mistake? What would have been the correct way to solve it if it was incorrect? Okay, so I'm gonna send you into breakout rooms here. And then I will come and visit the breakout rooms as you are working on this activity. Yeah, so we'll have about 4 people in each room. I think that makes sense. All right, so I'm gonna open the rooms. You should get a message to join, and then I will move around. Okay, so let's really quickly go through these questions. So the first question was about Zach and his crayons. Which operation would the keyword strategy direct you to use to solve this problem? Addition, right?
How many would be addition, but it's a multi-step problem.
Right, addition isn't, well, you could use addition, you could use repeated addition to solve this, but a more efficient way would be multiplication, right?
Right.
So I'm gonna just breeze through these problems, but as you would have noticed, the keywords would not have been very helpful for solving this set of problems. So I hope you all had time. I'm not sure if you had time to talk in your groups, but I hope you did, to talk about these questions about what are the pitfalls of using this strategy. So hopefully the first one that's obvious is that the strategy will often lead you to make a mistake and choose the wrong operation to solve, or to solve in a way that's really inefficient. So I hope that was clear to everyone. And then I wanted you to also think about a little bit more deeply about this. So what are the skills or competencies involved in problem solving that we really want students to learn and to take out into the world with them? So would you type into the chat, please, something that your group talked about in relation to answering that question? And then Cami, I still am struggling with the chat. Would you, as you see something, read it out for me?
Yes, ma'am.
Okay, I got it back up. Oh my goodness.
Okay. You got the chat back up?
Yes, I got it up. Okay, so it looks like one group was talking about using visuals to help students. Yes, so the strategy that's going to be the focus of what we do over the next 2 sessions does use visuals, and using visuals is a really great strategy on its own for helping students understand word problem solving. Looking at words and numbers together can get all jumbled up. Yes. Drawing out the problem. Yeah, so that's another way to use visuals. Graphic organizers, it's another form of visual. Students get stuck in one step. Yep. A lot of students, especially those who have working memory limitations, have a really hard time with multiple step problems. And those who have computation or fact fluency deficits also lose track of the bigger picture and really get zoned in on one little calculation and then sort of lose whatever steps are coming next. Okay, so something I wanted you to think about is how, with problem solving, what we really want students to learn, yeah, vocab is also an issue, is reasoning. We want students to be able to look at a problem, understand the problem situation, reason through it, and solve. That's the most important thing about problem solving that we want students to take out into the real world. We want students to be able to solve real problems, to be able to be presented with some information, to be able to make sense of it, and then solve to get an answer that will help them move forward. So I'm just looking at the chat here again. Keyword meanings depend on grade level, right? So that's another reason keyword is not great. Multiple expectations for vocab. Vocab is really tricky with word problems for a lot of reasons. One of our teachers shared the option of numberless word problems. Yeah, we're going to talk about that today too, or not today, in the next session. So Reasoning is really what we want to get from students when we're working with word problems, but the keyword strategy really takes reasoning out of the equation. We're teaching students to look for that keyword and then to hunt and peck for the numbers in the problem and just use an operation to solve. So we're sort of bypassing the whole bigger picture of why word problems are important, why we want students to learn to solve them. And it may, in some cases, work and help some students to solve some problems, but more often than not, students are going to make a lot of mistakes. They're not going to be able to generalize or transfer that learning to any other types of problems. So it's really limited in how useful it can be. So I think it's useful to talk about keyword strategy is something that's really common still. So I think it's useful to talk about it really quickly and why it's not that helpful for students before we transition and talk about a way of teaching problem solving that I think is a lot more useful and helpful for students. Any last thoughts about word problem solving using keyword strategy before we move forward? Go ahead and type in the chat. I'll keep an eye on it. Okay, so this is basically the information I just shared. Keyword often leads to wrong answers and really discourages or eliminates opportunities for students to use that math reasoning, which is really the whole point of focusing on word problem instruction. In addition, things like teaching students how to solve problems by operation, grouping problems by saying like, these are addition word problems, or these are subtraction word problems, or these are multiplication word problems, is really similar to the keyword approach in that it's really limited in how useful it is. When we're out in the world, we're not, problems aren't presented in that way to us, right? We've got to figure out what is the problem asking me to do. That's a big part of problem solving. So we want to teach students a way to solve problems that engages that reasoning. And then general problem solving strategies, heuristics, or acronyms, those sorts of problem solving strategies can be really useful, but they're often not supportive enough for students with disabilities. So I just wanted to say that really quickly before we move on. There are lots of great problem solving strategies, but students with disabilities tend to need a lot of support. So the way we're going to talk about teaching problem solving is going to include a lot more support. Okay, so we're going to focus on schema-based instruction. What is it? It's a method for word problem solving that focuses on reasoning. It teaches students to categorize problems into schemas. Schemas are really just categories. And then once you've identified the schema, you learn to use an efficient strategy to solve that type of problem, that category of problem. So in elementary, we work with both additive schemas and multiplicative schemas. Today, we're going to do a quick overview of the additive schemas, and then on day 3, we'll look at the multiplicative schemas. The way that we teach schema-based instruction is the same across all the schema categories. So the categories are important to understand, which is why we're going to spend some time on the additive schemas today. But what we really want to focus on is how do we use this approach. Schema-based instruction is considered an evidence-based practice for students with disabilities. There's a lot of research on schema-based instruction. I'm not going to spend the time that we have today to go over it with you. But if you were just to get into Google Scholar and search schema-based instruction, you would find a ton of articles and intervention studies that have used this approach and found really great results for students with disabilities at all different grade levels and with different disability categories. So these are the categories or the schemas. The additive schemas are the combine or total schema, the compare or difference schema, and the change schema. And the multiplicative schemas are equal groups, comparison, and proportions or ratios. The first schema we're going to look at is the additive schema, combine or total. So what you see on this slide are examples of combine or total problems. I want you to spend a couple of seconds reading these problems and then thinking about how could you define this category of problem? What do they have in common? How would you describe this type of problem? So take a second to do that and type what you think into the chat, and I'll watch the chat until we have a few responses there. So again, what I want you to think about and type in the chat, what do these problems have in common? How would you define or describe the category? And try to avoid talking about operations. Okay, multiple steps. I'm actually not sure. Do these all need multiple steps? That wasn't what I was looking for, but it could be true. Minimal keywords. Yeah, I think there are keywords in some of these, but not all. Parts and whole. Okay, that's combine, right? This is the combined total category, so that's a great word to describe what's happening here. We're combining sums. Parts and whole, that's really great way to think about this. Combined total. Can you put these into categories? Yeah, so you could put these into 2 subcategories. If you were thinking about how you'd write an equation to solve and label the terms, think about what's missing. So we've got 2 subcategories based on what you would be solving for here. All right, so I'm going to move forward. The definition of a combine or total problem, these are problems where we put 2 or more separate parts together to make a sum or total. So someone said parts and whole, that's a really similar thought process. The student-friendly definition, the definition we would teach to students when we introduce this schema, is we put 2 parts together for a total. So that's the introductory definition. For older students, it could be we put multiple parts together for a total. The graphic organizer that we use in the schema-based approach to teach combine or total problems looks like this. We've got part 1 box plus part 2 equals total. This is what the equation looks like. And you can also use a gesture in teaching these. Typically, it's the lower grade teachers that like to use the gesture. But for the combined total schema, the gesture looks like this. There are 2 parts, and you've got your hands apart. And we put them together. You would clasp your hands together to say, and we put them together for a total. So we've got 2 parts that we put together for a total. There are 2 different types of combined total problems. Total missing problems, where we're going to need to solve to find the total. So an example of that is Emily saw 4 blue jays and 5 cardinals. How many birds did Emily see? Birds is the total quantity, right? We've got 2 parts, blue jays and cardinals, and we're putting those together to find the total number of birds. We can also have part missing problems. Emily saw 9 birds. If 4 of the birds were cardinals, how many were blue jays? So in this problem, we have the total and we have 1 part. We're going to solve for the missing part. The solution strategy for total missing problems is to add the parts together. And the solution strategy for part missing problems is to either subtract the given part from the total to find the missing part, or to count on from the part that we're given to the total to find the missing part. I know I'm moving pretty quickly through this, but I want us to be able to cover the additive schemas before we wrap up for today. And I've got all of this information for you in handouts as well. I'll show you in a moment. So when you're teaching, when you're introducing a schema to students, and we'll talk more specifically in the next session about what those lessons look like. But just for today, when we're introducing schemas students, I like to provide them with a FRAIR model, like what you see here, to help them organize the different information that helps them keep track of what the schemas mean and how we solve. So this is an example of a FRAIR model for a total missing problem in the combined schema. We've got the definition in the upper left corner, an example problem with the parts and the total labeled in the right top corner. In the bottom left quadrant, we've got the equation, and then we've got our solution strategy in the bottom right. So this is an example of a completely filled out graphic organizer for a model that you can have students work on. Like, yes, it is like a graphic organizer. I like to, let me see. Yes, this is the document that you have in the Google Drive folder. So you've got the completed FRAIR model, but this is what I like to actually use with students, these incomplete FRAIR models, so that as you teach these pieces of the definition for this schema, you have students fill these in so that they can keep this page in their math notebook, or you could create a class chart that looks like that, however it is that you like to provide references for your students in your math class. So that's, this is like a guided notes version of the FRAIR model with the missing information. So the students fill in or complete this as you teach the strategy. So you've got access to the full set of these in the Google Drive. I just wanted to pop over and show you that really quickly. Okay. So the next additive schema is called the compare schema or the difference schema. And again, this is a list of problems that all fall under the category of compare or difference schema. And we're going to do the same thing here. I want you to look at these for a moment and think about what do these have in common, and how would you define or describe this schema? So remember, when we looked at the combine or the total schema a moment ago, the definition is two parts or several parts that we put together for a total. Think about what the definition would be here. What do these problems have in common? What would you teach students is the way to define this category? So take a minute and think that through, and then type your definition or your ideas about what a definition would be into the chat, and I'll keep an eye on that. See, somebody's asking about the link for the Google documents. I'll post that back up here as well while I'm keeping an eye. Oh, I didn't send that to everyone. Okay, compare bigger and smaller amounts to find the difference. Right, that's exactly it. I feel like you may have looked ahead a slide. That's okay, that's great. Here again, I'm putting into the chat the link if you still need it. So compare problems, compare a larger amount and a smaller amount to find a difference. That's the definition of the schema, or how we can group those problems together. The student-friendly definition is that we're comparing a bigger amount and a smaller amount for a difference. The graphic organizer looks like this. We've got a capital B for bigger amount minus a lowercase s for smaller amount equals a difference. And the gesture for this one, there's a bigger amount, use your left hand at head level. So there's a bigger amount, and a smaller amount, you put your right hand down at your chest level. And then you shake your hands to say we're comparing the bigger amount and the smaller amount to find a difference. There are three types of compare problems: difference missing, bigger amount missing, and smaller amount missing. So again, this is all the different iterations of what we might be solving for, right? When we're looking at compare problems. The next couple of slides, again, have just examples of what a difference missing, bigger amount missing, and smaller amount missing problems look like, as well as the solution strategies. And again, there are these FRAIR models that include all of that same information. Okay, and our final additive schema is the change schema. So we've got some example problems here, and I want to do the same thing here. Just read these through and think about what makes this set of problems hang together as a group. What do they have in common? How would you define this set of problems? So just think about that for a moment. Beginning point, change happens, increase or decrease. Exactly, great. So change problems have a start amount, then something happens, and that start amount either increases or decreases. Exactly. For students, you could teach a start amount that increases or a start amount that decreases. Here are the graphic organizers, the equations. The gesture for this one looks like this. There's a start amount. You shake your fist at chest level. There's a start amount. Something changes and the amount increases, or the amount decreases. To decrease, you can't see me, but I'm shaking my fist down at my hip. Okay, we've got examples of the 3 different types of problems, the solution strategies for each, and then these FRAIR models for each. So that was a really, really quick drive-by of the 3 different additive schemas and all the different types of problems that we teach within each schema. This slide is just a graphic organizer for you, just as reference for you. This is in the Google Drive as well. It's got all of the additive schemas, examples of all the types of problems within each schema, the equations, explanation of the gesture, and the graphic organizers. So again, this is in the Google Drive for you.
And they also received the hard copy in their folders.
Oh, good. So you've got a copy of that too. And that's really for you. I wouldn't give that to students, obviously elementary age students. That's a lot of information. That's just a reference. So I had a great breakout group activity planned, and I think what we'll do is I'll just ask you to do that before our next session, because we're running pretty low on time. It looks like we've got about 2 or 3 minutes left, so we won't go into breakout groups. But this activity is to help you get a little bit more familiar with all of those additive schemas. So I'm just going to pull up the activity sheet and talk through the activity with you. This should take you just a few minutes to do, and I think is worthwhile in terms of getting comfortable with the schemas. So the direction.
Just so you know.
Okay, so you've got a hard copy of this as well. There's a little typo here. There are more than 3 of each type of schema. So 3 is a misnomer. You've got 4 or 5 of some of the different types of schemas. So ignore that 3. But you've got several of each type of schema problem: combine, compare, and change. The definitions are here again for you. And what you're going to do is identify the schema for each problem. So be really specific. Don't just say it's a change problem. Say it's a change increase problem. Or not just a compare problem, it's a compare bigger amount missing problem. So go ahead and when you do this, read the problems, classify them into the additive schemas, determine what schema they are. And then when you're finished with that, see if you can write a new problem for each schema. I think taking the time to try to write a problem yourself will really help cement your learning about what the schemas are. So if you could do that before we meet again, that will really help you as we move forward with how we're going to teach students to use the schemas to solve problems. Okay, so the answers are there also. So try to resist the urge to just look ahead and find the problems or find the answers. Work through it, and I think you'll find that that's useful. So today we reviewed why word problems are really difficult for students with disabilities. We reviewed why the keyword strategy is not effective. We learned a little bit about what schema-based instruction is. And we learned about the additive schemas. We just did a big overview of additive schemas. Next time, we're going to look at how to implement the first phase of schema-based instruction. So how do we put this into practice with students is what we're going to focus on in the next 2 sessions.